Thanks, Brent, for the introduction, and good day to all of the listeners to this webinar presentation. I'm Craig Macdonald, as Brent highlighted. I'm going to be talking to you about lithium from spodumene and giving you an Australian perspective. What I want to talk about today is the current sources of global lithium supply, focusing specifically on spodumene mineral, and then talking a little bit about spodumene mineral plants, and then moving on to current spodumene producers in Australia. We have several lithium hydroxide chemical plants in construction, and we're going to talk a little bit about them and then discuss the outlook in Australia in terms of lithium from spodumene. Current sources of lithium supply. There are really three main sources of lithium supply. Lithium from brines comprises approximately 60% of the known reserves. What we're talking about in terms of lithium brines is a lithium-bearing high salt concentration liquor, which is recovered from underground, and then the water is evaporated on surface. And then the salt is harvested to recover the lithium metal. The focus of this presentation is going to be on hard rock and pegmatite deposits. So spodumene is hosted in the pegmatites, and approximately 30% of the known global reserves of lithium is in pegmatite deposits. And that would be a typical open cast hard rock operation. Supply is hosted in sedimentary deposits or clay deposits. But really today, when we're talking about lithium production or lithium supply, the two main sources are lithium from brines or from hard rock pegmatite deposits. This here is going to be on spodumene in pegmatite deposits. Moving on to the lithium supply by country. The table there shows the major producers of lithium globally in 2020, and we're talking about lithium in metal, lithium metal in concentrates. You can see that Australia has a market leading position currently and around about 50% of global supply. The other major producers are Chile, China, and Argentina. Chile and Argentina produce the lithium from brines, and China has production coming from both brines and hard rock pegmatites. It's noteworthy that this is a 2020 snapshot. In 2021, Australia was able to increase their production by over 35% from their hard rock pegmatite operations. What we're looking at there is a lithium-bearing pegmatite from an Australian operation. Some of the characteristics of spodumene. Spodumene is actually one of the lithium-bearing minerals found in pegmatites. We also have petalite and lepidolite. Spodumene and petalite are both lithium aluminum silicates, while lepidolite is a lithium-bearing mica. You can see the chemical formula there for spodumene. What is important to realize is the lithium content of pure spodumene is at 3.7%, so perhaps lower than what one would expect. When we talk about lithium content, we normally express it as lithium oxide or lithia, and the lithia content is around about 8% in pure spodumene. Another feature of the pegmatites is that you find tantalite is often hosted in the pegmatites and recovered as a byproduct. Some of the operations have cassiterite, which is the tin-bearing mineral, which is also hosted in the pegmatites. The benchmark price for spodumene is spodumene with a grade of 6% lithia. What we've seen over the last 5 or 6 years is price volatility and a range between $400 and currently over $2,500 a ton. What we saw starting from 2019, the end of 2019, going into the COVID pandemic, the price really dropping off. And then from about the middle of 2021, we saw a real hockey stick upturn in the price. And in the June of 2022 quarter, prices of $5,000 a ton have been reported. So what we can say is the price has been very volatile of late. I think what we're really more interested in is the processing of spodumene. Some important features. A commercially recoverable ore typically has a grade of somewhere between 1 and 3% lithia. What we see in terms of density is that the spodumene has a SG of 3.18. So that's important to remember when you're talking about a dense medium separation operation. If you're trying to recover a 6% lithia, you're going to be targeting a solids SG of around about 2.95 or 3. A feature of the spodumene is the color. I always think of spodumene as a white or a grayish white mineral, but it does come in different shades. And certainly across the operations in Australia, you do see green, pink and purple shades. Liberation is an important feature, certainly an important factor when looking at a new resource and designing a plant. What we find is the liberation typically occurs somewhere around 3 to 6 millimeters, but in some operations we've seen mineral liberation up to 15 millimeters. In its natural state, the crystals are in an alpha spodumene, or what's known as an alpha spodumene. So that's that image on the top right shows the alpha spodumene crystal structure, and for the academically inclined, the green circles are actually lithium. The importance of this is probably more in terms of lithium hydroxide production. What we see in the bottom right is the alpha spodumene in a scanning electron micrograph. For those operating spodumene concentrators, what you see, the image in the bottom left, is a typical 6% lithia spodumene concentrate, and the top size there would be around about 5 millimeters. Moving on to some of the spodumene mineral plants that we see in Australia. This particular flow sheet is a simplification of the Pilbara Minerals original plant at Pilgangoora. What you see there is the run-of-mine feed being fed through primary and secondary crushing. The material is sized and stockpiled and then fed to an HPGR. and then once again sized to produce a -4 millimeter product for dense medium separation. So you can see from the DMS sizing screen, we feed in this particular case into a 2-stage DMS or dense medium separation. It has to be said that this flow sheet is just one version. There are many different dense medium separation flow sheets. Sometimes the operators have a rougher and cleaner type of system. In other operations, they might have a rougher and scavenger. So in this particular case, what's happening is the floats or the cyclone overflow is recovered, and that's producing the HMS concentrate. The sinks in this particular case is recovering a tantalite concentrate. What happens is the rejects from HMS and the fines is actually ground in a grinding mill. We then, from the grinding mill circuit, we tap off a -1 millimeter product, which is fed through spirals. The concentrate from the spirals is producing a tantalite concentrate. The fine product from the milling circuit is passed through an upflow classifier to recover mica, and then the underflow is fed to spodumene mineral flotation. The concentrate from flotation is then passed through magnetic separation, and then the product is dewatered in a pressure filter to produce a cake, which is the fine spodumene concentrate. So that would be typical of a plant with both dense medium separation and flotation, and also a plant that would be recovering tantalite as a byproduct. What sort of challenges have we seen in these plants? The benchmark grade for spodumene concentrates is a 6% lithia. Some of the operators are producing 5.5% and 5%, and in some cases as low as 4%. And the lower the higher the grade of, well, the lower the grade of concentrate, typically the higher the recovery. So there is a trade-off. It's important to consider the liberation, not just when the plant is built, but the liberation of the spodumene does vary across the ore reserve. So it's important to monitor during operation. And what we're seeing, what should be obvious, is we're seeing a combination of both dense medium separation and flotation being used to recover the spodumene mineral. Some plants have a combination of both. Some are purely dense medium separation, and others are flotation only. Basalt is present in most of the operations in Australia. Basalt is an important consideration because the density of the basalt is very close to that of the spodumene. So it's important to consider in the dense medium separation of operation. What should be obvious is the difference in color. The basalt is black or dark grey, where the spodumene mineral is a white or a greyish white color. So it's very easy to see in the plant, either in the run-of-mine ore or in the concentrate. Techniques to remove the basalt are through ore sorting. Ore sorters have been successfully used in some of the operations. In other operations, they use high-intensity magnetic separation. The basalt is actually paramagnetic, so you can remove the basalt with magnets. Another problem is mica. A picture tells 1,000 words. So what you can see there is the light and flaky mica particles on a vibrating screen deck. What happens is the mica can blind the screen decks and reduce the screening efficiency, which has a negative effect on the overall operation. So mica needs to be considered. Mica removal is often done using upflow or reflux classifiers, where the upcurrent of the water removes the light and flaky mica particles. Other things that have been reported in terms of the spodumene operations in Australia is mineral flotation can be affected by water quality, and a feature is the abrasive wear due to the very sharp crystal structure of the spodumene particles. If we start talking now about the producers in Australia, I tend to look at them in terms of three categories. There's the established producers, there's let's call them the recent producers, and then there's some emerging producers. Talison is the largest and most established operation in Australia. It's in fact the largest producer of lithium in the world. They operate their Greenbushes mine, which is approximately 250 kilometers south of Perth in Western Australia. They've been producing lithium or spodumene since the early 80s. They operate both DMS and flotation plants, and they do produce tantalite as a byproduct. Noteworthy that they have three co-owners, namely Tianqi from China, Albemarle from the US, and the Independence Group, which is an Australian-based mining company. Currently, they export their spodumene concentrate, but due to the fact that Tianqi and Albemarle are both building lithium hydroxide plants in Australia, there will be more spodumene being diverted to those lithium hydroxide plants. Galaxy have their Mount Catalan operation, which is near Ravensthorpe in Western Australia. They operate DMS plants. They actually treat 3 different size fractions, and they have a very large top size. And they merged with the South American company Ocacobra in 2021. If we move on to some of the some of the recent producers that commenced operations in the mid-2010s. Pilbara Minerals started up about 4 years ago. You can see the map there, which shows the operation. It's approximately 100 kilometers due south of Port Hedland. Port Hedland is the main iron ore export port facility in Australia. Starting up at around about the same time was the Alturia lithium operation. About 2 years ago, Pilbara Minerals actually bought the Alturia operation, and they now, as a consequence, have 2 operating plants on the site. They use both dense medium separation and flotation to recover the spodumene, and they're planning expansions to more or less triple their production going into the future. Mineral Resources is an Australian-based mining company and mining contractor. They started operating at Mount Marion in 2016. They built the Wodgina operation to recover lithium, and that started up this year. Albemarle is currently building the lithium hydroxide plant at Kemerton near Bunbury. And what happened is there is now a joint venture between Mineral Resources and Albemarle, and that is a JV around the Wodgina and the Kemerton lithium hydroxide operations. So what you've got there is the Mount Marion operation, which is a dense medium separation and flotation recovery plant. And then that's the Wodgina operation, which is just milling and flotation. Moving on to some of the emerging producers. Bald Hill started operating in the mid-2010s. They stopped for a while. They're now under new ownership, and they recommenced in late 2021. They have a DMS plant. Core Lithium are building their Finniss mine in the Northern Territory near Darwin, and they're going to be putting in a DMS plant. Covalent Lithium is a joint venture between Wesfarmers, which is a large Australian corporate, and SQM, which is an established lithium producer from Chile. They've got the Mount Holland mine in construction currently. They're also building a lithium hydroxide plant. And then there's the Kathleen Valley operation, which is in the Goldfields region of Western Australia. They're looking at putting in a milling and flotation plant. So where are these operations within Australia? So what we've got there is an image of the, let's call it the western half of Australia. So Talison and Galaxy are both in the south. They are the established producers. We look at some of the recent producers. You've got Mount Marion, which is just south of the famous gold mining town of Kalgoorlie, and then Pilbara Minerals, which is up in the Pilbara. Talking about the emerging producers, we've got Mount Holland down in the south between Perth and Kalgoorlie, Kathleen Valley in the Goldfields region, Wodgina, which is basically adjacent to Pilbara Minerals, and then the Core Lithium's operation at Darwin, or near Darwin. So what do we do with the spodumene concentrate? It's relevant to start talking about lithium hydroxide chemical plants because, like I said, there's several being built in Australia currently. This slide is really a typical spodumene to lithium hydroxide process flow sheet. Spodumene is fed into a rotary kiln and calcined at a temperature of around about 1000 degrees C. If you recall earlier, the natural crystal state of the spodumene is an alpha crystal state. It's converted into a beta crystal state. The solid is then milled, and then sulfuric acid is added and then introduced into a second rotary kiln for an acid roast. The solid product from the second kiln is then introduced into a water leach, and the lithium and other metals go into solution. We then pass the slurry into a liquid solid separation step, and the lithium is in the liquor. Magnesium and calcium are precipitated out. We then clarify the liquor in a filtration step. The lithium is then concentrated in an ion exchange step. Sodium hydroxide is then added and then passed onto a Glauber salt crystallizer. Glauber salt is actually hydrous sodium sulfate. The crystals from the Glauber salt crystallizer go to a liquid solid separation step in the form of a centrifuge. The solids from the centrifuge are then remelted and then recrystallized in an anhydrous sodium sulfate crystallizer, passed on to another centrifuge, dried, and then the sodium sulfate is bagged and sold off as a byproduct. What is more interesting perhaps is the lithium, which remains in the liquor from the centrifuge. It's then passed on to a crude lithium hydroxide crystallizer step. There may be more than one crude lithium hydroxide crystallizer. This is basically purification from this point onwards. The solids from the crude lithium crystallizer is then passed on to a centrifuge. The lithium hydroxide is redigested and then recrystallized in a pure lithium hydroxide crystallizer. The solids now are at an acceptable quality. It's then dewatered in a centrifuge, dried, and then bagged, and then sold off as the final product of lithium hydroxide. and that product is then sold to battery manufacturers. So if we're talking about Australian producers, the first operation of consequence is the Tianqi operation, which is based at Kwinana, which is the industrial area south of Perth. That image shows the Tianqi plant, and if you look carefully, you can see the rotary kilns in the foreground. There's actually two lines. You can see the crystallization plant in the background. And then here to the, if you see the pointer, in this sort of area is where the covalent lithium plant is currently under construction. So basically, Tianqi and Covalent are building plants that are almost next door to each other. The third important plant is the Albemarle plant, which is being built near Bunbury. So what do things look like in terms of lithium production from Australia going into the future? There's going to be a focus on maintaining spodumene grade in final concentrate, but I think probably more importantly, an increased focus in terms of mineral recovery from the spodumene plants, the spodumene concentrator plants. We're going to see more spodumene in concentrate for export, but we're going to see the exciting development of lithium hydroxide being manufactured in Australia for production and being sold off to battery manufacturers. I think what should be clear is Australia has been an early mover in terms of lithium production and will remain well positioned going into the future. Thanks for your attention.